So we're going to continue with function power standard 2, and we're going to look at lesson 2. So we're going to determine that slope that you just got done learning about in lesson 1, and I'm going to introduce what is known as the y-intercept, and we're going to look at them as properties of the linear function given in a graph. So we'll get started here. First thing is just a reminder of the vocabulary of slope, and slope is how steep a straight line is. So we talked about positive slopes, negative slopes, undefined slopes, and slopes of 0. It just depends on how steep a line is. So if you think about a hill and you're standing on top, or you're skiing, you look at the slopes that you could go. You can go Black Diamond, or I would ski the bunny slope if maybe. But slopes, again, are how steep a straight line is. Now, in algebra, we use the letter M to represent a slope. So when we look at, here in a little bit, the equation for slope, we're going to look at that letter M to represent slope. And that letter M is always multiplied by that value of x. So value of x is independent. It just depends on the situation we're in. But that value of x, which is a variable, and remember, variable means they vary, so you can't put a number on that x. X can be any number. So M is your slope, and it's being multiplied by your x. The new thing to talk about is called a y-intercept, and just like it sounds, it's a intercept. It's a point where the straight line intercepts with the y-axis, and hence the reason why it's called a y-intercept. Again, it's where the line, that straight linear line that we've been looking at, and how steep it is, the slope of it, and we're going to look at in particular, where does it hit the y-axis? And where it hits that y-axis, or known as the intercept, that is where it's known as the y-intercept, and that is going to be the number b. So when we look at the equation, slope has a number because it's a certain slope of the line. B has a number because it's a certain spot where it crosses the y-intercept, or the y-axis. So those two, M and B, get replaced with letters. The other things in there, the x and the y, are variables. They vary. They aren't one point. It's not a steepness. It's not a point where something crosses. And what is always true about the y-intercept? One thing that I always talk about is that y-intercept is 0. The x is 0, and then the y is any value where it crosses. Okay, so let's look at this intercept form. Now, in algebra, you're going to learn next year, there's different types of slopes, different types of equations for linear. Slope-intercept is the one we learned first because it's just like it looks. It talks about its slope, it talks about the y-intercept, and then you make the formula. So the formula for the equation that uses a slope, and we can put in here y-intercept, okay, is y equals mx plus b. Y equals mx plus b. Just coloring it so you get used to it. You might as well just memorize that. Y equals mx plus b, you can get on YouTube, you can look up videos that sing that to you over and over, but y equals mx plus b, y equals mx plus b is an equation you're going to use multiple times next year in algebra. Again, remember M is the slope, how steep a line is. We talked about the rise over the run, how high it goes up versus how high, or we know as the horizontal distance. The B is the y-intercept. Okay, so M, slope, how steep a line is. B, where the line crosses the y-axis. So we're just going to look today at graphs. So here's our beautiful graph. Okay, so to be able to make the equations, this is the point of this lesson, is you have to find the slope because it's a certain number, and you have to find the y-intercept because it's a certain number. Then you go ahead and you put it into the equation. So the question first is always, what is the slope of this graph? Write it as rise over run. In other words, write it as a fraction or a ratio. So we got to find 2 points that cross. It looks like it crosses right here. It looks like it crosses up here. It's a positive slope. I can see that it's up going. So I'm going to look at this as a rise. Remember, I like my slope triangles. So, and it's going by 1. So 1, 2, 3. So it has a rise of 3 and a run of 1. So I can write that as 3 over 1. Again, rise is on top, or the y values. I talked about that in the last video, over the run, the change in the x. Now, new part, y-intercept. Seriously, totally easy when looking at a graph. Here's my lovely little line going up, going up, going up, going up. Whoop, there it goes. Right there, it crosses the y-axis. It's as simple as that. Look at it. Where's it across the y-axis? It crosses at 1. Now, you write it as a quartered pair, like I reminded you. X is always 0 because it's on the y-axis, and x right here is always 0 on the y-axis. And then you just write where it crosses 1. Done. And the last part is just put it in the equation format I showed you over here. So it's going to be y, the variable y, equals m, the slope, always the variable x, plus always the y-intercept. Y equals mx plus b. So sing it to yourself. Y equals, you look up there because I told you m is a certain number. This line has a slope of 3 over 1, or you could write that as just 3. X is the variable. It varies. You can't give it a value when you're making just a straight up equation, plus the y-intercept. No, when you put the y-intercept, you don't put the ordered pair, you just put the y value. Again, you can rewrite it like this. It's a lot easier to look at if you write it as just 3 instead of 3 over 1. There is an example of how to put an equation of a line in slope-intercept form. Another example here. Same 3 questions. What is the slope? So let's get going here. This one nicely kind of shows us. We'll just do our slope triangle right here. Okay, I can tell it's going down. So right now, sometimes I just put negative so I don't forget. So my rise, nicely going by 1. So it's going down to 1, 2 over 1. So my slope is negative 2 over 1. My y-intercept, follow along. Whoop, there it is. Crosses my y-axis. There's an intersection, whatever you want to call it. Crosses there. Let me erase it because I kind of slobbered all over it. Right there. So that is at 0, 5. And then remember, y equals mx plus b. Y is a variable, so it stays y. M is the slope. In this case, it was negative 2 over 1x. That's the slope, or how steep mathematically that line is. X is a variable, doesn't change to a number. It's just x. It varies, plus your y-intercept, which is b. So that is your first look at writing slope-intercept form equations to represent the line looking at a graph. I hope this helps, and I can't wait to teach you the next form to look at.